All right. So, good job. All right. So question to the class. If you have an angle, see, it's not one of the angles that you would have learned. For example, 30 degree, 45 degree, 90 degree, 75 degree, 120 degree, whatever. Let's say you have a number that's it's an odd number and it's not divisible by 5. For example, let's say you have 42. See, let's say you have an angle of 42 degrees. Which instrument do you think is the best instrument to use to draw an angle of 45 degrees? Meaning, when I say instrument, meaning, use TD with pencil, T-square, set square, compass, protractor. Which instrument do you think is the best to use in that case? Anybody at all? What's the number we say? A 42-degree angle. All right, so let's quickly. So nobody wants to try? Or is it you guys don't understand the question? Go again.
I'm asking if you could repeat.
Or if I could repeat.
Yes, sir.
All right, so the question is, if you have, for example, a 42-degree angle, which instrument would be the best to use to draw that angle? All right, no idea. That's fine. At least don't be afraid to say don't know, guys. I just want to hear a response. All right. So better than said no idea. All right, so I'm gonna share my screen. I'm gonna share my screen. One of these now. See this? Fabulous. Here it is. So when you're using traditional methods, meaning you're not using AutoCAD, you're using pencil, ruler, T-square, like in the olden days before they introduced AutoCAD into schools, right? This is what persons would use. This is called a protractor. See the name here? Protractor. This is what you would use to draw. You can use this to draw an angle of any measurement between 0 and 180 degrees. Are we seeing it? See it here? See a clear one over here? From 0 all the way around to 180 degrees. So whereas you can use your compass and pencil, right? Let me show you what a compass is for those who either don't know or probably don't remember. Yeah, this is a compass. So when you would draw your circle in AutoCAD and allow your circles to intersect so that you can bisect a line or bisect an angle, if you're using the traditional method, you'd actually use a compass and a pencil to make those arcs, right? So, but the compass and pencil will allow you to make angles such as using certain construction methods. Wait till I Yeah, certain construction methods will allow you to make angles such as 30°, 60°, 45°, 90°, 120°, and they go increments of 15 basically. Not that you can't get it smaller than that, but it's going to be a whole lot of work. So if you, the instrument that would be best, that's a key word, best to draw an angle that is, let's say 47 degrees or 23 degrees would be a protractor, because you don't have to use any construction methods. Just simply find the angle that you want, and as you see here, 0, 10, 15. So each of these darker lines represents 5 degrees. So 0, 5, 10, 15, 20 going around, and these smaller ones, smaller ones represent 1 degree. So it's easier to use this, it's quicker, that's for one, way quicker, and it's also accurate in terms of drawing angles that do not have any traditional construction methods. So any number that is an even number and it is not divisible by 5. Everybody following that?
Yes, sir.
All right. All right, so back to it now. Where are my tabs? Okay. All right, next topic. All right. Does everybody know, does everybody remember how to calculate the area of a triangle? Oh, what is the formula for the area of a triangle?
Half base times height.
All right, did everybody hear that? Half base times height? All right, so moving on. Let me drop this quickly. All right, yeah. So, all right, so when you're bisecting an angle of 90 degrees, let's say you have the 90-degree angle already drawn. Let me use the whiteboard. Oh. Is everybody seeing the screen?
Yes, sir.
All right. So let's say I have my 90-degree angle. See? And I want to bisect that 90-degree angle to form a 45-degree angle. What is the next step in that procedure? Anybody? Adams, Lewis? All right, wonderful. Creating the arc or the circle. All right, so using this thing have different colors. Don't use the different colors. Using here as a center, you would create a circle or an arc. Cutting the 90-degree line and cutting the horizontal line. And then what would be the next step? All right, for the sake of time, I'm just gonna go ahead. So the next step would basically to use where the arc, oops. Let me get this thing figure. All right. All right, so yeah, these 2 points, kind of hard to get the dot. So we just use that. Those 2 points as a center. And then from there, from each of those points, you would draw an arc. And where those points intersect, you draw a line from the origin, which is that blue spot, through those intersecting points. So line.
Sir, the two arcs at the top comes from the 2 points that you made. The two.
Yes, the 2, whatever color it's red or pink, right? Those 2 points. Yeah, so the idea is to be able to look at a diagram of an angle being intersected and being able to tell what angle is being intersected or being created, right? Just by looking at it, just the construction method. See? So if it's a case where, where's it clear? It's a case where you have and let's say your origin was right. So just by looking at that, what angle is being constructed there? All right, wait, don't answer yet. Let me change just the point. Point the two. Kind of. Yeah. What angle is being constructed there? Without me even drawing the line. What degree?
Sir, is it 6?
60, yes. 60 degrees. Right? So we should have draw the line from here. So let's go on. Right? Not really accurate still, but yeah, get the idea. 60 degrees. So just being able to look on the construction method, even without seeing the line drawn. Because once you see the line drawn, you can estimate it now. Can we draw a line here? So you can basically estimate and say that come like a 30 degree. See? That would be a 60. This would probably be a 45. This would probably be a 90. Well, the 90 the lean still, but you get the idea. See? So without me drawing the line, just looking at the construction method, you should be able to tell what kind of angle is being constructed. So, all right, so clear off everybody. Let me jump to the next topic. All right, whiteboard again. All right, so we have a circle. Oops. Line again. No, the other direction. Make sure I resize this thing. Oops. I'm gonna just put 11, guy, easy to draw, right? All right. So basically, that's what you're seeing on the screen is labeling or dimensioning a circle that has a diameter of 11, right? I know work in millimeters, so 11 millimeters. The fact that the two arrows in the center of the circle, or the line in the center of the circle, the two arrows, right? It goes through the center of the circle, somewhere here. That is denoting the diameter of a circle. So if it was radius, you'd only have a line going from the center to the edge of the circle. See? So this is a part that would have not in there. Or one of the parts would not be in there. Instead of having this as the diameter symbol, now we all know that this is the diameter symbol, right? Oh, my bad, somebody's in the way to me. Yeah, thanks for that, Night. I probably should have just. See if we can quickly. Type in diameter and radius. Share my screen. Close the whiteboard for a moment. Share my screen. Here we go. All right, so as you can see here, radius is from the center to the circumference of the circle, and the diameter is a line that runs through the center of the circle and touches both ends. The symbol for diameter is just a circle with a line through it, right? Simple like this, like a cancellation sign. There's a circle with a line through it. And the symbol for radius is just a common R. Yeah, see it over this side, a common R. That's the symbol for radius. And that's not only in geometry, it's also in, not only in TD, but also in math and geometry, right? Symbol for radius is R, the letter R. So as long as you can identify that on a diagram, which one is pointing to the radius, which one is pointing to the diameter, it should be fine. All right, moving on to the next topic. All right, so if it is that you are using traditional methods, meaning, as we say, pencil, ruler, T-square, set square, compass, protractor, right? If a draftsman wants to draw, or a person wants to draw a perfectly horizontal line, perfectly horizontal, what instrument should that person use? Check if anybody's in the waiting room. Cool. All right, anybody want to give it a shot? Somebody said T-square, wonderful. Zane said if you want to draw a perfectly horizontal line using traditional methods, you'd have to use a T-square. Everybody know what T-square look like, right? I'm gonna share my screen quickly. For those who may not be sure what it looks like. Yeah, there we go. That is a T-square. So usually what we would do back in our days, see this picture in the middle, so we would have to put the T-square at the side of the board, and you have to ensure that the boards are made for technical joint, because if the boards are not perfectly squared, it's going to throw off a joint. So we'd have a joint board, put the T-square at the side, rest the paper. So basically put the T-square down here. So rest the paper on top of the T-square, ensure that the paper is perfectly horizontal on the board. Then we tape it down using joint tape it down in the four corners, and then you would use your T-square to draw all of the horizontal lines on a joint. And it was fun, I'm not gonna lie. And you know, it had its disadvantages, but it also had its advantages. You never remember no commands, right? And sometimes you can beat the system too. For example, if you can make a certain curve, you can kind of get away by freehanding it. So that was fun. All right, so next topic.
Sarah, when you drew the circle, what were you saying about the diameter last connect?
What was I saying about the diameter and what?
I'm saying that I had lost connection.
Oh. All I was saying is that let me just go back quickly. You guys need to know how to identify when the radius of a circle is being labeled and when the diameter of a circle is being labeled. See? Which you shouldn't worry about. I'm just going to go over it just in case. So I'm going to share my screen quickly again. Yeah, so it's going to be from the center of the circle, an arrow pointing from the center of the circle to the edge of the circle, or the circumference. That's for radius, and the symbol is just a common R, just like here, common R. For diameter, it is a line with a two-sided arrow, an arrow on both ends of a line that runs through the center of a circle and touches the circumference of the circle on both sides, right? And the symbol for a diameter is basically the cancellation sign. Which is just a circle that strike through. See? Symbol for diameter. All right, so next one. Hey guys, as I said in the group, you guys will be getting 25 multiple choice questions. All right, so question again. When in AutoCAD, Zine, when you're doing your lettering, how do you do your lettering? Is it in sentence case, meaning each word that is, for example, start a sentence is a capital letter and then all of the other letters are common, except for when you're talking about, you know, specific people, specific places, etc. Right? Or do we work in all caps? You guys, all caps, wonderful. So once you're working in AutoCAD, when you're dimensioning or labeling your drawings, we always work in all caps in AutoCAD, right? That's the next topic. And let's look on a few quadrilaterals quickly. All right, let me share my screen. Zoom. All right, let me share my screen, sharing screen. Let's run through them quickly. All right, so we have square. Everybody know the characteristics of a square. 4 equal sides. All sides are straight. All sides are the same length. All internal angles 90 degrees. Rectangle. 4 straight sides. All angles, internal angles are 90 degrees. Each opposite side is the same length. The opposite sides are the same length. Parallelogram, opposite sides are the same length. And what do you call this now? Opposite angles are the same, But all of the 4 angles are not the same. So you have these 2 angles are different than this and that. So it says 2 opposing pairs of equal angles. A rhombus has four equal sides like a square. The rhombus is like a square bent out of shape. It's like if you kind of tilt your head to the right, it's kind of like a diamond. See? So that's a rhombus. Four equal sides. Opposing sides are parallel. So the opposite sides are parallel. These lines on the left and on the right are parallel to each other, running in the same direction. Lines at the top and at the at the bottom run in the same direction. They are parallel. And you have also, just like the parallelogram, two opposing pairs of equal angles. And then you have a kite, which is like still kind of a diamond shape, but one side kind of long. Where they have two pairs of equal sides. So this side equal to this side, that side equal to that side. But that's technically all it is. One opposing pair of equal angles, and these two angles are the same. So just one pair. This angle is different than that angle. You have a trapezium. All right, somebody saying something, or you might just turn on. All right. And moving forward, trapezium, it has one pair of parallel sides. So just one pair alone, one pair of parallel sides. This and this. But this not parallel to this. And they have no equal angles. All right, so this angle different from this angle different from this. I'm not really sure about it. This is no equal angles, but oh, this kind of contradicting right still, because this is a 90-degree angle, and clearly this is a 90-degree angle. So I don't know if I make some mistake here. Right? But let's just stick to the fact that it has one pair of parallel sides, which is that's all. Yes. These two lines are running in the same direction. These are running on a different angle from over here. I have isosceles trapezium, one pair of equal sides, which is this and this, one pair of parallel sides. Sorry, this and this is the equal sides. This left and right equal sides, meaning same length. And then top and bottom, though they're not the same length, but they are parallel, running in the same direction. We have two pairs of equal angles, which would be, one pair would be at the base and the other pair would be at the top. Then you have an irregular or an irregular quadrilateral, which is no equal sides, no equal side lengths, no parallel sides. So none of the sides are not parallel, none of the length are not parallel, none of the angles are not equal. So as you know, this meeting is being recorded, so you can watch it back, because I know some of it's a bit much, so you can rewind it and look on the characteristics of each of the quadrilaterals. But the first couple easy, like square, rectangle, quadrilateral. Yeah. All right, so next topic. Right, so here now I have to go in whiteboard. Whiteboard. All right, so if it is that